Hi class, in this video I'll be showing you how to set up a simple dataset using SPSS. If you quickly look at the bottom of your SPSS, you may notice that there are two types of views, data view and variable view. Data view is where you will actually input in your data to be analyzed, whereas variable view is where you will define your variables such that you can organize your data. It is recommended to always set up your variable view first before inputting anything in the data view, as it will help keep your dataset clean and concise. That being said, let's go to variable view. Notice how there are several different columns. I'll briefly describe each of these columns as they pertain to the class. The first column is name, which is where we will actually define our variable. One thing to note about this column is that you cannot use space, otherwise SPSS will not be able to read it. For example, let me use the example of I class. Notice how it says the variable name contains an illegal character. Now, how do we circumvent this? You can just use an underscore, and then it will allow us to input the data. So now our first variable, will be defined as class high. In order to clear this, just right-click on the variable you want to clear, and then click on clear. And then it'll bring us back to a blank slate. Let's keep our data set empty for now, as we will be using a specific data set posted on Canvas for this video. The next column is the type of variable it is. Click on the ellipse. Notice how there are a lot of different options. For this class, we'll only be worrying about numeric and string. So numeric is when you're using numeric numbers for your data, such as 1, 2, 3, 4. This will most likely be your default option, and the option that we will be using the most in most of our data set. The second variable we will be using in this class is called string. Notice how when I click on string, it shows characters. String allows us to use alphabetical characters for our data set. For example, if we want to examine a player's name, we would have to use string such that it will allow us to type out the player's name. Characters is how many amount of alphabetical letters you can use. So for example, since it is 8 characters, we can use up to 8 alphabetical letters in our variable. Width is simply how far your data is from the width of the column. Normally we just leave that as default. It doesn't really matter too much. Decimal is how many decimal spaces that will be shown for your data set. For example, if we're using 0 decimal space, a numeric value of 2 will simply be shown as 2. But if we use a decimal space of 2, it will show 2 decimal space. Let me show an example. We go to data view. Let's type in 2 with 2 decimal space. Notice how it is shown as 2.00. However, if we decrease that decimal space to 0, it will be shown just as 2. Let's clear the data. So labels is simply what the data will be shown as in the final analysis. That is, if you use label, you can override what the data name is called in the name section. Now you may be asking, what's the point of using label when you just name everything what you want it to be? Well, for example, if you have a data set of 100 data, you might want to just name everything 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 through 100. And then when you're actually analyzing everything, you can group it using the label function. Therefore, it will allow it simply to have your data be more clean and concise. And for in real world situations, where you will be using thousands, hundreds of data, right? You want to keep your data as clean and concise as possible. So the values section is used when we want to define a data that has no inherent numeric value. For example, gender. Well, a lot of survey studies uses gender, correct? However, can gender actually be analyzed without defining a value to it? No, it can't, because you can't analyze male, female, etc., right? There's no data to be analyzed there, right? So what we do is we have to assign a value to that gender or those genders. Let me just quickly show an example. So for example, we want to analyze the differences between a male and a female study habit. In order to do that, we have to first define male and female in numeric values such that we can analyze the data. So for value, you can just assign, for example, 0 for male and 1 for female. Now SPSS is able to analyze the difference between the data of male and female because there are numeric values for it to be able to read. We will probably be using this example later in the semester, but just keep in mind that if your data requires you to define a numeric value or assign a numeric value to it, then we'll be using the values tab. Note that the values you assign don't have to actually be any specific value, whatever is most convenient for you. And as long as you remember which value you assign to which label, any value can be used. For example, I could be using 0 as female and 1 as male, and it'll be the exact same thing as 0 as male and 1 as female, right? As long as I remember which value is assigned to which label. Quickly clear this. For missing values, this is simply so we can analyze values that are not inputted correctly in SPSS. In this class in particular, we don't really have any missing value. But for a real world example, suppose there's a survey study and there is 1,000 responses. You may quickly notice that some participant may just forget to write in a response. So in order to keep track of those data without having to discard that entire response variable, we just add in a missing value such that SPSS is able to acknowledge that, okay, there are missing data from this person's response, but we will still be able to analyze the rest of their responses that they provided. So you can just ignore columns and alignment. Again, they just show you how the data is aligned. That's just for clarity's sake. Like for example, left align means that your data will show up on the left, right align will show your data on the right, center shows in the center. In our class, we'll just keep everything as default. So measurement is important. Normally there will be a scale measurement as well. However, we would actually need to type in a data set first before it shows up. So notice how the two options that are default available is nominal and ordinal. Those are basically data sets that have no real numeric value. Nominal, for example, is just anything that pertains to any data in general, such as your name, for example, or what team a person is on. Ordinal is a ranking scale measurement, where, for example, you want to rank your data. For example, the most common use of ordinal it would be places in a race, for example, first place, second place, third place. Notice how there is a ranking system in that data, right? So we're not going to be using roll. This is for more advanced statistics, so don't worry too much about this. Okay, now that I've shown you what each of these functions do, let's actually type in a data set. Let's use a data set that is provided on Canvas for MLB 2016 player salary. So let's examine the top 25 player salary for the MLB players for the 2016 season. So First thing first, we have to define the data we want to examine, correct? Let's look at the players. So our first data will be players, their position, their age, and lastly, their salary. Notice how we have two different type of data. There are data that pertain to numeric values, which are age and salary. And then there are data that had no numeric value at all, correct? So players and position. So let's go to data view and notice how after inputting those variable in, it'll create 4 different columns. Now let's try to, without changing anything, type in our player name. So our first player is Kershaw. Notice how it just won't let me do it, correct? That's because we're currently using a numeric type of data. Therefore, we can only use numbers in our data set. So for players and position, we'll first have to click on the ellipse and change it to a string data set. Let's change character to 12, simply because some of these names can get kind of lengthy. And then position, also change it to string. And then we'll also allow 12 characters. Okay, so let's go back to data view and let's see the difference. So let's try to type Kershaw again. Notice how SPSS is allowing me to type in the player's name using alphabetical values now, right? That's because I'm using a string, which allowed SPSS to read my alphabetical data. Okay, let's just type in the 25 names for the players that we're going to examine. So now that we have the player's name inputted, let's assign the position they play into the data set as well, such that we are able to associate the player's position. Next, let's associate an age with these players. So once again, let's go to variable view and let's define the measurement as scale. Notice how we are now able to select a scale function. Scale function is used when the data has a numeric value associated with it. So for age and salary, since age and salary both have numeric meaning to it, we're going to change these measurements both to scale. Now let's quickly type in the data. And lastly, let's type in the data for salary. Note that these salaries are based off millions. Therefore, this is 34.57 million, 34 million, and so forth. It doesn't mean their salary is $34, correct? It's just shorthanded, so we don't have to type out the entire value. So actually reviewing this, I actually forgot to add a data. So therefore, if I were to be acknowledging that I forgot to add in a data, I would normally put a random value that I would not be analyzing. That will allow SPSS to read the data that I'm missing. Therefore, even though I forgot to add in all of the data, I can still analyze the data set without having to redo everything. However, for this class, we're not going to be covering missing data, so I'll just re-input everything. It just shows the importance of being able to double check your data set. For example, in a real world where a data set is much larger, something like this can be disastrous, right? Because we'd have to go back and just examine thousands upon thousands of data. Luckily, we're just using a small data set right now, so I can just go back and double check everything. Perfect. So now we have a simple data set that is set up for the 2016 salary of MLB players. Notice how everything is pretty clear and concise. Now for the actual analysis, let's examine the central tendencies to see the mean values of the mean, median, and mode of each of the players' salary. So in order to do that, we'll go to Analyze. We'll be using Descriptive Statistics, and we're going to be using Frequencies. So what we're interested in is the mean, median, and mode of the player's salary. So we'll be highlighting salary, and you can either drag it over here, or you can highlight it and click the arrow key, and it'll drag it over here. So we're going to be clicking on Statistics, and then notice on the far right, there are options for the central tendencies. We're going to be selecting mean, median, and mode. So the quick reminder, the mean is the average, this will allow us to examine the average salary of all the players. The median is the middle average. Therefore, it's going to show us which is the middle salary out of the middle end of the salaries. Mode is the most reoccurring number or the most frequent number. Therefore, this will allow us to examine which salary is the most common. So click continue, click OK. Okay, so according to SPSS, the average salary for this top 25 players is around 24.53 million. The median salary is around 23,000, and the most common or frequent salary is 25 million. So that's interesting because we will notice that the mean salary or the average salary is actually less than the most common salary. So 4 players are being paid 25 million, and there are actually much less players that are being paid 25 million than the most common salary for the 2016 season. Okay, that's it for the basics of SPSS, how to set up your data set and how to quickly examine the average salary of the MLB baseball players for the 2016 season. That's it for this video. Remember, stay safe and have a good one.